Hello, mathematicians on the internet. Let's talk about square root functions and shifting parent functions. So, as you remember, all functions are input-output machines. The square root function is just when you put an x value into the machine, it takes the square root of it and kicks out a height value, or y. Remember that any function, you can plug in an x, get a y, and that's a point on your graph. So if I were to plug in a 1 for x, put that into the machine, root 1 is just 1, so the output, the height, is 1. If I were to plug in a 4, root 4 is 2, so the height is 2, and so 4, 2 is on my graph. So little t-chart here, x, y. 1, 1 is on my graph. 4, 2 is on my graph. Now, what would be another nice number to choose that could get us a nice answer here for another point on our graph? Think about your perfect squares. 1 times 1, 2 times 2, 3 times 3 maybe? 9. 9, 3 would also be on the graph. And so it does continue to climb here. So every function you can graph just by creating a table of values here and plugging in x values and getting out y values. But once you're familiar with this graph here, there's a lot that we can do to use this and graph related functions. This is what we call like the parent equation or parent function, because it's like the simplest function that we can write with a square root. There's no additions, no plus or minus anything, no x plus something inside, no coefficients other than 1. So it's just y equals root x, and this is the graph of y equals root x. Okay? So, what about shifting functions? Well, if we think about, the y equals the height value, and that's an output. Let's say we have y equals half root x. Well, if I put in a 1 there, just like, and it's a slightly different function related to this one. If I put in a 1 here, well, root 1 is 1. And then I cut that in half. So my output would be half of this here. If I put a 4 in here, okay, if I put a 4 in, root 4 is 2. But if I multiply 2 times a half, it cuts it in half. So instead of an output of 2, I get an output of 1, half of that. You could put a 9 in here, and then you get a root 9, which is 3, half of 3. Oh, that's 1.5. So maybe not as nice to graph that one. But do you see what this is doing compared to the parent function? This just kind of compresses it down by a half. Okay? So instead of over 1 up 1, like here, you'd have over 1 up half. And instead of over 4 up 2, you go over 4 still, but you only go up 2. So all the heights are compressed down. Okay? So a number here compresses the heights. Okay? Now, in the homework I saw a problem like this, but it had a plus 2 on the end of it. Okay, what does that do? Well, if I put a 1 in here, multiply it by a half, I get a half. Okay, kind of like that. But then I'd have to add 2 to get a height 2 above what I got for this one. So it still compresses the graph, so it's still the same type of curve, but the entire curve starts 2 above. So how do we draw that? Well, everything is just moved up 2, and yet it's the same curve as I see here. It just starts in a different place. So we often consider this number off the end to be like this is a vertical shift number. It moves the graph up or down this amount, and doesn't change the curve, but just moves the whole thing up or down. So here's my parent function, goes through 1, like this, goes through 4, 2, like that. So my parent function is, ooh, that's not quite right. Okay, a little better. Okay, goes through 1, 1, goes through 4, 2. Okay, so this is y equals root x. Okay, and then I have this one right here without the 2, and that just shrinks it down to half. So all these values are kind of half as high. Okay, so that's this one here. Okay, now I have that same curve, except I've moved everything up 2. So I'm going to start here, and see how this goes 1 over and half up. If I just go 1 over and half up, then I can have the same curve. If I go 4 over, okay, from here, 4 over, and then 1 up rather than 2, it's about right here-ish, about right there. And so there we go. Yeah, so this right here is y equals 1/2 root x. And this right here is the same type of curve as this, just shifted up. So that's y equals 1/2 root x plus 2. All right? Now, we can also shift these functions left or right. Okay? So you might have to rewind to kind of understand what's happening here with the vertical shift. But if I want to shift a function left or right, okay, I'm going to start back here with our parent function. Okay? What I do here is x is actually a left or right number, and y is a height number, right? And so, you know, if I add, you know, something off here, you know, it might shift it up. It's a vertical shift. But you know, you calculate this and then you move everything up 3 to get something 3 higher. But if I want to move something left or right, I have to put the number in with the x and change that left or right indicator here. So let's do -1. Oh, -1. Huh. Okay. So what does that look like? Well, again, you could use just a table of values to graph this. Let's think about our parent function. Parent function starts here and goes through 1, 1. Okay, like this, and then goes through 2, 4. Okay, about here. So our parent function is this nice kind of curve like this. Okay, I'm just gonna clean that up a bit. So yeah, so that's y equals root x. Right? It's our parent function. Okay, so we want to do this. So I put in a 1, 1 to get this, right? So if I put in a 1 here, what's 1 minus 1? 1 minus 1 is 0. And so if I put in a 1, I get root 0. Huh, that's strange. So where is this graph? What was actually happening with it? Let's try some other numbers. Put some other numbers in. Okay, so what if I put in a 5? If I put in a 5, 5 minus 1 is 4. So root 4 is 2. Okay, so 5 minus 1 is this, and that equals this, right? So 5, 2. All right. So where's 5, 2? 1, 2, 3, 4, 5, and then it's up here. Huh. It looks like that just kind of shifted over. Shifted over, doesn't it? Didn't it? And we did try to put in a 1, right? So 1 minus 1, it's root 0. Huh. Interesting. Root 0, it's kind of like, is that 0? Okay, so 1, 0. So we start here, and we're going to go up through here like this. So what happened to our graph? Oops. I just really colored over that. What happened to our graph here? The whole graph shifted to the right. Then usually, this is what we consider positive x. This is the x-axis, and this is positive, and over here is negative, right? But here, this x take away 1, it actually shifted our graph to the right. So a left-right shift is often the opposite, the direction that you'd think it'd go. So what have we covered here? We've covered kind of several different moves compared to a parent graph. We've covered what happens when there's something out in front here like this. We've covered what happens if there's a plus or minus something in here, like a b. And then we've covered what happens if there's plus or minus something out here. So this is a vertical shift, up or down. This is a horizontal shift, left or right. And this is a shrink, kind of a expansion, contraction. I might call it a vertical shrink. Okay, so a compression of the graph. All right, and that's how we shift square root functions. But all other functions shift very similarly. So this applies to square root functions and quadratic functions and exponential functions. We'll be doing those next.